And in the same exact way, we can do f sub y magnitude should be equal to this equation, right? A sub y, which is our force value, our weight at the diagonal, which is 3.924, times sine of the angle. And again, we're using the radian angle. This is what we should be getting for our forces, right? For our weights in the x direction and in the y direction. But what we actually got in real life was this is the x direction, this is the y direction. So we want to see the percent error in it. And we've talked about the last time to find the percent error, you need to use the equation. Let me pull it up over here. I'll type it out here. Insert equation. So percent error is equal to, and we're doing absolute value of all of it. We want to use isn't it bracket? Oh, right here. Absolute value of a fraction. And the whole fraction on top is accepted value minus experimental value, all divided by the accepted value. And at the end is multiplied by 100%, right? This is the equation for our percent error. So we're going to do this exact calculation for our values of horizontal component of x and horizontal component of y. And notice this one, we got a positive number already. There's no need to put an absolute value in front because we're solving for the fy magnitude because it's already positive, right? Looking at this, the vertical component of this is already a positive number. So it's not going to show us negative anyways. So going back to this, percent error is equal to, and I'm going to type in exactly what the equation we just typed into the Word doc, absolute value, ABS, parentheses, I put two parentheses out because I'm doing a fraction on top, right? Accepted minus what we got. Now, experimental for fx magnitude is fx weight, the magnitude of the weight, right? Close parentheses, divided by accepted, close parentheses, times 100. 2%. Now, exactly the same thing for this, equals ABS, parentheses, parentheses, accepted minus experimental, close parentheses, divided by accepted, close parentheses, times 100%, 1.122%. So these are really good data, right? Obviously, it's really good because they made up the numbers, but yours may be a little bit different. So this is the whole analysis for your lab number 3, task 2. So on your lab report, you should copy and paste your tables and put them into your lab report. And if you think that a diagram, something like what I drew over here, is going to help, you might either want to draw it on Paint and copy and paste it, or draw it on Word doc, copy and paste it, or draw it, take a picture and put it in your lab report. Whatever you think is going to help a reader of the lab report understand your lab better is useful. Okay. So if you have any questions, feel free to message me. But if not, I'll see you guys on Monday.